Hi guys, this is A2 Chemistry Transition Elements and we are looking at the color of transition metal complexes. Question 7. The octahedral complex NiH2O6 2 positive is green. Explain the origin of the color of this complex. Binding of H2O molecules, which are ligands, creates an energy gap between the two sets of d orbitals. An electron from the lower set absorbs visible light in the red and blue region and is promoted. The mixture of the complementary colors result in the complex ion appearing green. So red and blue light is absorbed. Their complementary colors when mixed together result in the green color of the nickel 2 plus aqueous ion. Question 8. When the solution containing the complex CuCl2 minus is poured into water, a precipitate of CuCl is formed. CuCl is white because it does not absorb visible light. Explain why CuCl does not absorb visible light. So CuCl contains the ion Cu positive. So Cu positive ion has a completely spilled d orbital configuration because of which electrons do not absorb visible light, hence are not promoted. As a result, Cu positive ion compounds do not appear colored. Next, the complex ion CrH2O6 3 positive is colored because it absorbs visible light. The absorption spectrum of CrH2O6 3 positive is shown. So it absorbs in the, if this is violet over here, then this should be blue, blue region, and this is close enough to the red region. So it absorbs in the blue and the red region. So suggest the color of this complex and explain your answer. So light is absorbed in the blue and red region because of which the color of the complex appears green. because the complementary colors of blue and red, when mixed together, form a green color. So the color of the chromium 3 positive aqueous ion would be green. Question 9. There are two isomeric complex ions with the formula CrNH3 4 times Cl twice positive. One is green and the other is violet. Suggest the type of isomerism shown by these complex ions. So we have six monodentate ligands, four of which are ammonia and two of which are chloride. So the chloride can be positioned on the adjacent positions on the octahedral complex, making a cis isomer, or they can be placed diagonally opposite to one another, forming the trans isomer. So the type of isomer shown is either cis trans or it is also known as geometrical. Next, explain why these two complex ions are colored. D orbitals are split into two sets. Electron from the lower set absorbs visible light and gets promoted. The color complementary to the wavelength of light absorbed is observed, and that is why these two complex ions are colored. Explain why these two complex ions have different colors. So the d orbital energy gap created in the two isomers are of different sizes, because of which they absorb different wavelengths of visible light and hence are appearing to have different colors. Since the energy gap is of different size, the wavelength of light absorbed would be different and the complementary color to the wavelength absorbed would also be different. So both the isomers will have different colors. Question 10. Cobalt is a transition element that forms complex ions with oxidation states +2 and +3. Explain what is meant by the term transition element. An element of the D block that forms at least one stable ion in which the d orbitals are partially filled. So that is the definition of a transition element. The following scheme shows some reactions of COH2O6 2 positive ion, basically cobalt aqueous ion. So on reaction with OH negative, it forms a precipitate A, which is cobalt hydroxide. In excess of chloride ion, it forms solution B, which is COCl42 minus, and in excess ammonia, it forms a brown solution, which is CONH3 6 whole twice, 2 positive. State the formula of each of the following. A, the formula would be COOH twice, H2O 4 times. Then we would have B, which would be COCl4, and the charge would be 2 negative. And then we would have C, which would be CONH3 6 whole charge 2 positive. Next, they've asked state the color of the following solution. So COH2O6 2 positive is a pink solution. Solution B appears blue, and solution C appears brown. Question 11. Explain why transition metal complexes are colored. Ligands create an energy gap between the two sets of d orbitals. An electron from the lower set absorbs a wavelength of visible light and gets promoted. The color complementary to the one absorbed is observed. Next, CuH2O6 2 positive is pale blue, but CuNH3 4 times H2 twice is deep purple blue. Suggest a reason for this. Ammonia causes a larger energy gap between the two sets of d orbitals. Hence, the color observed is deeper. So basically, the larger the energy gap created, the deeper would be the color observed, and the smaller the energy gap would be created, the lighter would be the color. Next, the diagram shows the visible spectrum of a solution of VH2O6 3 positive. State and explain what color the solution is. So it has its maximum absorption in the blue and the red region. So the complement of blue and red when combined will give a green colored solution. So the color of the vanadium 3 positive aqueous ion would be green. Explanation. So maximum absorption is in the blue and red region, The complementary colors of which combine to give a green color to the complex ion solution. Question 12. Explain the origin of color in transition element complexes. So, binding of ligands split the d orbitals into two energy levels with a gap between them. An electron from the lower level absorbs a wavelength of visible light and gets promoted to the higher level. The color observed is complementary to the wavelength of light absorbed, and that is the origin of color in transition element complexes.